exercise 3.6, we're looking at solving polynomial equations. First technique, isolating the variable by hand. So we just want to transpose the equations to the variables by itself on the left-hand side, and just remember the reverse operations when doing so. So we have, in problem 1, this particular cubic. So it's 3 lots of x plus 4 cubed plus 24. First job, subtract 24 from both sides. Then divide both sides by 3. Then take the third root of both sides, so x plus 4 cubed is just going to become x plus 4. And negative 8, we're looking at taking the third root of negative 8. So in other words, what number, when multiplied by itself 3 times over, is equal to negative 8? And of course, that's negative 2. So I now have x plus 4 equals negative 2. If I subtract 4 from both sides, you can see that I end up with x equaling negative 6. The next technique we take a look at is factorising and then applying the null factor law. Let's look at A. We've got x to the power of 4 plus 16x squared. Divide both sides by x squared, and so obviously x to the power of 4 is going to become x squared. And now let's take the square root of both sides and I get plus or minus 4. B. I've got this polynomial and it's equal to 0. I need to solve for x. Firstly, I'm going to try and establish a linear factor. So if I substitute 1 into the polynomial, I produce 0. That then tells me that x minus 1 is a linear factor of this cubic. So I set up for long division. Here's my cubic. I'm dividing by x minus 1. You can see my steps. I produce a remainder of 0, as I should, because x minus 1 is a linear factor. But when I've got this cubic, I divide it by x minus 1. The result is this quadratic. Looking at this quadratic, you can see I can factorise that to get 2x minus 3 multiplied by x minus 3. Of course, I can use the grid method or PSF. And there's all my workings. So what is it that I have? P of x is equal to this particular cubic, which is equal to 0. The cubic can be factorised to become x minus 1, 2x minus 3, x minus 3. And of course, we know that P of x is equal to 0. So in your notes, put in an equal 0 there. So if P of x is equal to 0, then it must be true with the null factor law that either x minus 1 is equal to 0, 2x minus 3 is equal to 0, or x minus 3 is equal to 0. And from there, we can solve for x. So the values of x which satisfy P of x equaling 0 are x equaling 1, x equaling 3 on 2, x equaling 3. In other words, if you substitute any of these values into P of x, you will have an answer of 0. Problem 3. We need to use CAS to solve this equation. I write it down, and here I've given approximate answers because the CAS solutions are very complicated. Wherever possible, give exact values. In this particular case, it wasn't, so I've just written down decimal approximates. Let's take a look at what happens with the CAS. So here we have our CAS, and so it's just simply going to be menu, algebra, solve, and I'm going to put in the cubic, so it's x to the power of 3 plus 3 lots of x squared minus 8x, take away 5, is equal to 0, and I'm solving for x. There's my approximate answers given. If I were to go back and put my calculator into exact mode, settings, document settings, you can see here calculation mode is auto. If I set this to exact and just go OK, go back into that problem. Command C, hit enter. And if I now perform this, you can see it's extremely complicated. All right, but usually you wouldn't get something so complicated, so you should put down the solutions that you see in exact format. For this particular problem, it was very complex. That's why I gave decimal approximates.